see, I'm going to talk about design patterns in test automation, right? So before I start, I want to start off with a disclaimer. Generally, when we talk about design patterns, we think it's like a magic bullet, right? It's like a golden bullet coming in, it can solve anything for us. I want to start with a disclaimer. It's not that. It's not going to solve all your problems. So when you're actually using a pattern into your test automation, see what your problem is and see what problem can be solved by a pattern. So don't look for some very cool pattern, because probably 6-7 years back when I was pairing with developers, I see this really cool code, right, sitting in there. So I want to try to use it in test automation. So don't do that. See what's your problem, see what can fit in for your problem. It's contextual, right? And the next thing, I want to set some expectations for this session. I'm not going to talk about 23, 24 design patterns today, and I'm not going to run each of these design patterns to tell you what these design patterns are, how they can fit where, and things like that. So what you can expect from this talk is I'm going to share my experiences as a QA engineer, where I've built a lot of frameworks, done some consulting, and I'm going to talk about when you build a test automation framework, some of my problems that I've faced, and I've picked some of them, okay, because given it's only 35-40 minutes, and I was asking if I can get about half a day to talk a lot about my problems and a lot of design patterns. Sadly, I can't get that. So I've just picked some of the problems which I want to share with you folks today, and how these design patterns actually help me rescue from there, right? And what are the advantages I got by adding these design patterns in my test code. Cool. So before we get in, how many of you have used design patterns in your test automation code? 1, 2. Okay. Okay. In general, design patterns, right? Whether it's test automation code or code, how many of you have used design patterns? Okay, I see some extra hands coming up, right? What kind of patterns have you used? Factory pattern. Okay, there's one pattern here. Singleton. Sorry? Chain of responsibility. So fluent APIs, right? Fluent APIs. Okay, so we have some patterns, right? You've used some patterns based on certain workflows and stuff, right? Before we start into jumping into the design patterns that I want to share with the context, how many know Solid in the room? Okay, not a lot of hands. So, but I'll quickly touch base Solid. I'm not going to jump into detailed into Solid. Probably consider it like a kickstart of a Solid, right? People have not heard about Solid principles. This is one of the principle in design pattern that I'm going to touch. There are lots, but I'm going to touch only one principle because it's very much needed for the next 30 minutes for us, right? So single responsibility principle, like the term talks, which S stands for, it's basically says that try to keep your test classes or your test case have a single responsible, right? Don't do a lot of things inside it. Keep it very focused to one specific responsibility, right? And try avoiding creating test classes, test cases, uh, which can do too many things, right? Probably one's going to do login, log out, or probably check out, and you don't try to bring everything into one specific class. If you ask me why shouldn't I do this, right? Basically it becomes harder to maintain and also debug for you, right? So always keep that in mind when you want to put down something. Single responsibility should be something which you want to always think about, right? Open close principle, like the term itself says, like open and close, right? So always make sure that your test automation framework should be open for extension and close for modification, right? So if I can slightly relate to something, let's say when you want to add a new scenario into your test suite, so your framework should be built in such a way that your existing modules should be you should be able to reuse them, right? You should extend it rather than going in and making a lot of changes, right? Again, you can ask me, hey, why should I do this, right? Because this definitely minimizes the risk for you of breaking your existing test, right? Because if you see, sometimes we go change a lot of, we try to refactor, we do a lot of changes, and again you'll have to run your entire suite, right? How many of you have bumped into that situation, right? Like you change something and you want to make sure that oh, probably I change, I want to see if all my other remaining 40-50 whatever number of your cases are working, right? I've been there in that state. The Liskov substitution principle is basically ensure your derived test classes can be used interchangeably. Okay, and interface segregation, write clear and focused interfaces, right? Because what happens is when you try to have a lot of things in your interface and you try to implement that, right, maybe some of those methods you don't really need them, you're forced to implement them, right? So try not to do that. Don't keep it smaller and very focused, right? And dependency inversion, your high level test cases basically should not depend on your low level implementations, right? It should only depend on your abstractions. And you can ask me, hey, how could this be? We'll see some examples for that. Okay, that's why I'm trying to put these points into your head so you can relate when you're talking about patterns and how my problems were able to pick these patterns, right? And one example, if I can relate, how many QAs in the room? Like QAs? Okay, how many devs in the room? Okay, and few other personas, right? Probably like cloud, infra, maybe managers, tech leads, and stuff. Okay, cool. The reason for me to ask is I want to see how I can connect with you all to reach these patterns, because these are not very specific to a role like a dev or a QA. These can be also, I was talking to a few people on infra, right? You can also have these inside infra. I think the next talk is also somewhere touch basing and all, right? So these patterns can be everywhere, not only test, right? It can be in your dev codes, it can be in your infra codes as well. So my problem statement, right? I want to start off with my problem statement because I've been talking about that, right? So I picked one problem statement over here where I was working for one of the clients and one of the projects where it was a cross-platform piece where there was web, Android, iOS. There's a backend, and there's also it also has some piece of event-driven system like Kafka, right? Most of you know event-driven systems here, right? So that was also in place. So when it came up to, I'm not going to touch base the test pyramid to talk about unit and integrations. And so my focus is more on the functional aspects of this. Okay, so I'm not going into how a pattern can go into integrations and unit. Definitely it can fit in, but my focus is slightly above the pyramid. So I had to build this framework which can support Android, iOS, web, and at the same time, it also, has this another feature down the lane, being keeping it more responsive as well, right? Like you open Safari or Chrome in your devices, you need to support that as well. And it, like I said, it also had a backend. So of course there was a scope of API automation as well, API testing in space as well. Along with that, it is also persona driven. So what I mean by persona driven is you'll be using a lot of applications to shop, right? Like Amazon and stuff. So there are different personas who can be probably like a retailer, like a supplier or a consumer, right? So different personas get different features, and different personas have different you know probably access level and things, right? So we need to consider all of that as well when we write our test automation framework, right? So this was my problem, and when I bumped on this problem, I started like anyone else. I started writing code, right? The first thing I would pick is you put up a walking skeleton, and then you put it in your CI, and you monitor. That was my style of writing as well. So started off with very very lean, right? So for the next probably 20 minutes, I'm going to share some of the code samples here. I'm going to walk people through, what patterns I've used, what was the problem, and why I followed that. Okay. So here, one thing probably I want to call out is, I'm not saying these are the best practices. I'm probably going to rephrase that to say good practices, right? So whatever fits in your context, please look through that, right? Probably for my context, whatever I'm going to talk next was working very well. Probably in your context it could be something else, right? So I'm not saying this, because this is the ultimate solution for you for this X problem, right? I'm going to share how these patterns actually help me in these problems. Let's go in quickly into the code base. I have some examples that I've brought in here, which can probably I believe I can connect. Okay, it's visible, right? Cool. So if you see what have I written over here, right? It's a simple API script, which all that it does is, it's making a get call, and it's just validating your request, right? It's whether it's a 200, and also there's a response over here, right? That's pretty much it is doing. So I'm basically initializing the fetch, and then I'm acting upon it by making an API call, and then whatever response come, I'm validating. It's a very pretty simple script, right? So, first script, I ran them into the pipeline, and things went very well. until slowly your problems start arising, right? Probably it's more on error handling, something failed, I couldn't figure out, so you go and make some improvements to this. And I did the same, right? So when something failed, we refactor, we go in and make things better. One thing I want to highlight is, if you look through the arrange part, right, I have something called as an API driver over here. The reason for me to put this API driver is, how many of you know this recent stuff with Postman, right? Postman moved from, Scratchpad to cloud, so you're forced to log into the cloud and things like that, right? So even when I was using some of these, HTTP libraries, uh, halfway through, I know something really works well, but when I get a new problem into my application which needs to support certain things, probably the library is not helping me, right? So what we tend to do, we see what could be the best fit for us, right? So we switch to the specific drivers. So similar cases, I initially started using node fetch in the JavaScript world. It's just simple HTTP client, okay? And I wanted something to be worked very well, but I couldn't configure a timeout for a specific version. But Axios had that. Now what happened was, my entire code base is so polluted with gets and posts and deletes and puts, right, across. It's very hard for me to go change in a lot of places and things, right? So the first thing I want to do, typically do, is abstract that out, okay, into something called as an API driver, right? And if you see over here, this class is just having a responsibility of the driver for me, which is Axios, right? And all that it typically does is it's creating an instance, of Axios, and simply making a request, right? That's pretty much it is doing. And now very clearly, tomorrow, if I want to move away from Axios completely, the only place that I need to come and change is the API driver, right? I simply change the API driver probably into probably node fetch or something else, right? Whatever you prefer to do. And again, if you see here, going back to solids, so I might keep bouncing back to solids back and forth, is the first thing that we spoke about was single responsibility, right? So you see this class is actually holding a single responsibility, and its responsibility is only about the driver. So it's only going to, instantiate your specific driver, and everything is going to be about driver, right? And the next thing is, let's go back. Okay. Then I have a fetch, right? Like the term simply calls, it's just simply making a, a make request. And if it fails, I'm going to catch this error. Very simple code, right? So there's nothing much to talk here. And now comes the problem for me, right? Now let's say, I've made a simple call, all is going good. And then the feature development happens, and I get this event-driven system into play, right? So, generally event-driven systems are like, you drop a message, you don't know when it's going to arrive, right? Probably it could be the third second, 10 second, but it's going to arrive, right? You could have some time that it could arrive, but generally when you make an HTTP call, you get in a post, it's always, it goes and comes back, right? But in an async world, it's very different. Right? Now, typically in the async world, what happens is a message is dropped, you make a get call, right? You'll have to, what happens then? I don't see that, message arrived over there. What typically we would do in this case? Anyone in the crowd? So I made a request, on the other side the sync has happened, but the message hasn't arrived. So typically what should happen in this case? My test will fail because it will go check for something it's not yet arrived into the specific database, right? What generally we would do in that case? Anyone? Retry, right? Okay, retry, right? So in this given context, where you do want to go and retry? So I have two classes, right? One is the API driver, one is a fetch, right? The fetch makes the API request. So, and the API driver is all that, just creates an instance, right? So where would we typically go and make this change, right? Anyone? Sorry? In fetch, right? So I would typically go in here and probably wrap it or put a entire polling system there, right? But if I do that, again, I'm going to go back to solids, right? I'm breaking something, right? The open close principle, right? So I'll have to make sure my suite is built in such a way it's open for extension but closed for modifications, right? But now what happens if we come in and change or try to put your polling or inside this, you are basically breaking that principle, right? And again, what happens, like I said, you'll have to again debug, put some console logs, put a debugger, see, the fetch is really happening, and things, right? So this is where I want to, this is where I started thinking what could actually help me to solve this problem, right? Because I don't want to, because this is a very simple snippet. So start thinking in your head, right? If your suite has grown bigger and bigger, when your application development is happening, so you need to evolve, right? As a product is evolving, your test also should evolve with it, right? Given in that state, I don't want to go and change and break the principle. So that's where I figured out we can actually use a pattern called a decorative pattern, right? Like the word itself says. Anyone heard about decorative pattern in the crowd? Right, 2 3 hands up and down, right? So basically, like the term says, right, decorative pattern. It's a similar concept, right? You have a cake, you create a base, then you apply the cream, you apply sprinklers and chocolates, and a lot of you make it high calorie after that, right? So it's a similar stuff. So you try to decorate the fetch with something, right? And what is that you want to decorate now in our case? Retry. So I'm going to call it polling, okay? So I'm going to put a polling there, and I would want to decorate that with polling. So all that I simply do is, I've already created this class called polling, okay? It's a simple polling class, which uh, also takes how long you want to poll, right? Now, if you see what I did, your test remains same, your fetch remains same, nothing has changed, right? You're only wrapping the entire polling with a part of your fetch. So this also, by doing this, I'm pretty sure that all my other tests would just work the same because we haven't changed anything on the request side, right? So now I've decorated the polling part. Now I also had another case, right? It's just not about, you can wrap as many decorators on top of each, right? I'll give another use case where I had to also decorate this for another issue, right? So this project where I also worked was heavy into compliances and audits. So I'm sure a lot of you would know about audits and compliances, right? Logging, screenshots, and I know it's a pain. Given that, when it came to lower environments and a higher environments, right? So lower environments like your developer environments or staging testing environments, however you have named it, right? And higher environments could be your pre-pod and your UAT environments, right? So we had different logging mechanisms for these, right? And it's very much needed for the audit purposes, even for you to promote, right? They could be, you could bump into that. I bumped into one of those situations. So what happens in those cases, right? I had to jump into, one part of Kibana logging, right? One was AWS cloud or probably Grafana, right? There were different logging mechanisms that we had to do. And again, and it's mandatory for these tests to log certain information and things, right? So what happens again? I can still go ahead and just simply wrap this into probably Kibana, right? And I can do as many decorators I want to add over here. So this way, I'm making sure I'm not breaking the principle, right? And if you see, what are the principles that we are satisfying here is a single responsibility principle. Like the API driver has its own responsibility, the fetch has got its own responsibility, polling, all that it does is just polling, right? And along with that, your test intent has not changed. I didn't make any changes to the existing test suite, right? And with that, there's another thing that we also do is your dependency injection. You are actually injecting the fetch into polling and polling into your Kibana or Grafana, right? So you are fixing into that entire principle. And also one more thing, as a simple example, maybe if you think through, also always think about dry, right? Don't repeat yourself. Whenever you're writing that code, always think about not repeating. What is that you can do best so that you don't make others' life harder, right? Who's looking at the code. And so that's one pattern, right? I'm going to jump into the second problem which I was talking through, which is I'll probably ask, I'll seek some help from you folks, right? I said, right, I have an Android iOS platforms as well as web as well as MWeb, right? So when we started off, it was pretty simple, saying that okay, we have an Android, we have a web, so we're building a very simple login logout feature, okay? So for web, it's pretty simple, right? So we know we log in and probably you're going to have some, user icon on the right top. However, your designs are there, you simply log out. But that was not the case with Android, right? Any mobile developers in the room? Any mobile devs? Oh, no worries. But all of us use mobile applications, right? And if you see, anyone use both Android and iOS, or you carry both, right? So some of the applications you see, they differ from Android to iOS for certain functionalities, right? Though you want to even still log out, probably in an Android you need to, probably swipe, scroll, and then log out. But in the web, it's very different, right? But the aim of your test case is still the same. So typically in this case, what we would generally do when you write a code, anyone in the crowd? Different classes. Yeah. So different classes, right? Or generally, when I started off, I started writing a simple if else to make things smoother. I want to kickstart it, right? So I didn't see it's okay not to, if else is not a bad code to put in. But when I got more implementations like for iOS or probably for MWeb, my entire test code got polluted with a lot of if else conditions, right? And it ended up with a code smell. So I didn't wanted that and I didn't like it, okay? So I sat with one of the developers and I asked what could be the best way that I can fix this problem, right? And that's when I was introduced to another pattern which is called as a factory pattern, right? So I'll very quickly run through how I was able to solve this a lot of if else polluting across the code with this pattern, right? And this time, probably when I get in, I'm going to call out something else. So I created a simple Android flow, right? And if someone noticed, right, the previous example I took was JavaScript. Now I've taken Java, so I've got different flavors of programming languages as well. Because like I said, design patterns can fit anywhere, right? It's language neutral. It can fit in anywhere for you, and it can also fit in infra. So I've taken a Java code over here for this specific example, right? So I've simply created, an Android flow because I want all my functionalities related to Android to be a part of it, and I have an execution, which is interface, right? Very concise, simple interface which can do a login, logout. And I also created a web flow over here, which talks about login, logout, right? Because login, logout is common between both Android as well as a web. And they have their own functionalities, right? Probably for an Android, you would simply go scroll, swipe, and then check out, log out. Whereas for web, you would simply, do a mouse over on an icon that would probably have a hover, and you would log out, right? So there are different steps that you would typically want to do. For a web, it could be 5 steps to log out, but for a Android, it's completely different, right? So then I want to create a factory over here, right? So what I did, we created a class, and all that we did was based on your platform that you want to run your test. All that we're doing is we are simply creating an object, whether it's a web flow, you simply create a web flow object and you return it, right? But how would my test look like? So let's go in and look at our test, right? How does my test look like? If you see through this, I'm only on runtime, I'm getting my platform from a driver, irrespective whether it's Android, iOS, web, or whatever that is, right? And what we do after that is all that I'm doing is I'm simply calling a login and a logout, right? And if you see this test based on your driver, it can actually work across platforms, right? Your test intent is not changed. So let's take an example, right, to extend this, right? So maybe tomorrow you have implementations for iOS coming into play. Like what changes you would want to do in this code base, right? All that you would simply want to do is create another flow which called as iOS flow, which implements your execution. That's your step one, right? And the second thing that you want to do is simply go into the factory, and all that you would tend to do is just return another iOS flow. That's it. Your test intent still remains the same for you. You don't have to change your test intent, right? And that's where we talk about extendability. And so this way, definitely for this problem which I saw, factory pattern really actually helped me over here. And the next thing is, I mean, like I said about this entire problem statement, right? I also bumped into another use case where, when you do a normal checkout, right? So we all do Amazon shopping, we do a lot of shopping, right? Retail. So what happens is we have different payment methods. Right? And when we bumped into the payment method, you have like credit card payments, probably PayPal, UPIs, or debits and credit cards and things, right? And when you choose a credit card, probably you will have an OTP, or probably when you do a PayPal, no OTPs. Or for a UPI, it's a different strategy, right? You get in. So even when I wanted to build this, when it was first 1 or 2, it was okay for me because it's 1 or 2 strategies. But when I did a lot more, we bumped into a lot of these payment methods, right? And that's where I thought, what could be the best way again to solve this problem, right? And if you look through, and that's where I found this another pattern called a strategy pattern. Anyone heard of this pattern called strategy pattern? 1% here. Okay, 2, 3. Okay, so again run through another piece of code to see how this pattern actually helped me solve this problem, right? And this time I've taken Python. Any Python fans in the room? Oh, nice. The reason I asked is I'm not much of a Python fan, but I still wanted to demonstrate it using Python because I knew we would have some Python users, right? Okay, so over here again I have an interface, and what this interface is typically doing for us over here is simple. Like I said, I have a payment method to be selected, and I want to complete my checkout. Very simple, right? Whether it's a credit card payment, PayPal, or what, and I want to complete my checkout process so that I can shop things. And the next thing is, I've created a credit card payment strategy class, right? And if you look through this, it implements payment strategy, right? It implements payment strategy over here. And I have two methods: select payment and complete payment. Right? Probably I want one thing for you to also observe. It's a simple WebDriver code, right? So we saw Node.js, we saw APIs. So this is a very simple Selenium code that I've written, which basically clicks, enters some piece of code, and at the same time it also enters your OTP, right? So for credit card payments, I need OTP. And my next way is a PayPal, right? So for my PayPal, I've implemented the same select payment method and complete. But if you observe, I don't need OTP, right? So this way I have clear uh, segregation of my classes. So each of these classes have their own responsibilities, right? Which is very, very important, right? And then I created a context called checkout to say complete checkout, right? So this is another class which I created, which is called as a complete checkout, right? And if you see how my test would look, which is very interesting here, this is where you need to see through, is my first part is, create this credit card payment strategy. And I give it the details, right? I would give my credit card, CVV, and etc. etc. And then I say, check out the process and complete the checkout, right? Very simple, very readable, very simple. And now when I want to change this to my PayPal or debit card or credit card, whatever, the other different types of payments, all that I do, I only change my payment strategy. So instead of doing a credit card payment, all that I would introduce to my test is a PayPal strategy, right? The next checkout process and your complete checkout process still remains the same. And this is where I was talking about dependency inversion, right? In Solid, your high level test should not depend on your low level implementations, right? Where is your implementation over here? Your implementation over here is clearly, which is low level, which is in your strategies, right? So this way, you also make sure that your test intents are intact. It has its own responsibilities as well for each of these strategies, right? And the next one I would probably want to also show is, how many of you have come into this whenever you write any code, right? Any test code that you would typically want to test it with different test data. A lot of hands here. And again, I'm not jumping into test data because that itself is a whole big topic, so I'm not going to test data. But typically what we tend to do is, for a specific test, you would probably have a dedicated test data, however you're creating, right? Probably you pick it from a database, you pick it from a JSON, whatever is your source, right? And what we tend to do is, probably we might write something like this, right? Let's see if anyone's familiar with this a simple code, right? How many of you are familiar with this piece of code like this? You try to create an object, and you put in values or your test data inside a constructor, right? Anyone familiar with this code? Okay, few hands coming up, right? So I see a problem in this. Okay, the problem I see over here is I definitely see a code smell, right? Not now, but let's say I only added sample product and a quantity is 3 and a price, right? What if I also wanted, add more properties to it? When you want to buy a product, probably I want to add some what do you call special notes, or probably I want to gift wrap it and things, right? Or probably you want to gift a 15 Pro to someone who you really love, so probably you want to put some greetings to it, right? So now what happens is this constructor argument keeps growing, right? When this constructor argument grows, that itself is a code smell. That's problem number one. Now, problem number two is we would tend to make mistakes, right? Human errors, because you need to keep in your head that the first name is a product name and a quantity and a price, right? You might see it on the screen because that's IDE helping me because it's a full version of IDE, but not every IDE would actually help you with that, right? So then you tend to, probably put a, price in the place of a quantity and quantity in the place of a price, right? So you really need to think, where what comes through. And how do we want to break this, right? Any pattern that you can think of breaking this? It could be a very common pattern I'm talking. Build a pattern, right? A build a pattern could come into a rescue over here, which can actually help you solve that problem, right? And how you minute, Probably I lost the signal. Do you want to? Okay. Anyways, by this I'll also show you how the builder pattern would look like, right? Before we'll come into that point, uh, I'll very quickly also re-look into what are the patterns we saw and what are the solid principles that we look through these patterns, right? The first pattern we saw was a decorative pattern, and what does it really, where did this fit into the solids, right? Minute. This always happens when you really want to show something, as a demo. You know what? Just my Mac did. It just restarted. Can you believe it? Right. So we looked in through dependency inversion, single responsibility principle, open close, as well as composition over inheritance for the decorative pattern. And the code sample 2 that we saw was a factory pattern where we spoke about our iOS and Android, right? So we spoke about iOS, Android problems and how these problems actually rescued us. And one such was a single responsibility and open close principle for a factory pattern. And the next one we saw was the strategy pattern, right? So this is where we were talking about the credit card payments, and also we were talking about payments of PayPal and things, right? So we actually held through single responsibility, interface segregation, right? When you look through interface segregation, like I said in the earlier slides, we were seeing how uh, literally you break your interfaces into tiny ones so that don't keep it monolithic, right? That's what we saw for a payment strategy as well. And the open close principle, right? And that's where, if you see through all the patterns that I've picked through, open close principle is one thing which comes in, your single responsibility comes in, right? But if you see, dependency inversion was in some cases. That's where I was telling, not all your patterns need to fit into solids, right? And the code 4, this is where I was wanting to show how a builder pattern would, and thanks to my Mac, it just forced me to not show you that. But I'll probably, it's a very simple one, so maybe we can catch up and show. Time's up. Oops. Okay, build a pattern, right? So build a pattern, again, it's got its own responsibilities as well over here, because you do a lot of your getters and setters into one class where you want to set and get your right test data, and then and again, that's again that also satisfies your open close principle. The reason being is, let's say in some cases you want to only create a data with quantity, probably another one you don't want to create a data with quantity, right? Maybe you can simply remove it. So that way, this also helps you in this case. So let's see what are the advantages, right? We spoke about a lot of patterns and how these patterns helped in certain problems, right? So the advantages of having these patterns in your test code, right, is basically reusability, right? So design patterns promote the reuse of your code and test logic, right? Like by encapsulating common testing techniques, your best practices within the patterns, you can simply apply them across any test cases by reducing your duplicate code, right? And also it also helps in maintaining your entire suite, right? Because when you make a change, the change in one place should help you reflect across your test code. So you can't go, okay, I want to make the change A, so let's go to 10, 10 or 20 places in my test code, I want to make the change. No, you don't want to do that, right? So you want to make sure that you make the change in one place and it actually reflects across your test code. Language neutral, which is very important. Like that's the reason I wanted to show that the patterns can be used in any of the programming languages. We saw in Python, we saw in JS, it could be anywhere actually, right? And also separation of a concern. This encourages, right, for us. The reason, for example, there's one pattern which I really didn't hear out when I asked for patterns, is page object pattern, right? How many of you use page object pattern? Like, okay, few from the QA background, right? So I didn't take that for other reasons. We can catch up offline to talk about it, but I'll probably talk about it now for a separation of concern, right? If you've used page objects, you know that you can separate your specific pages locators into one space, and probably you can have your actions and things like that, right? uh, and ease of training, this is very, very important, right? I'm sure that you always have people coming into your teams, And how many of you have done this, right? Where you give your entire suite and you are able to onboard that person? Anyone in this room? I think that's where you need to look through the way your test suite is written. If a person looks into your test code, right, you will have to be able to enable that person or make them understand that, okay, this is what the application is doing, right? Which is very important. Ease of training, that's another part which you have to always think through, why it is so important to think through about these patterns. With that said, right, I want to conclude saying that patterns are language neutral. They can fit in anywhere. And be aware, when you use your patterns, only when you have a problem, see what problem fit into what patterns. And also they fit into every landscape for you, right? Whether it's an API suite or whether it's an Android, iOS, or even at an integration level, right? It can fit in anywhere. So that's what I want to conclude and end this talk. And thank you so much for being very patient, listening to my story.